Okay, so I want to show you how to take your tweet file and turn it into a matrix so that you can use it for various data mining purposes. And in this case, you're going to use it to create the multi-dimensional scaling graph or image. I'm going to show you, I use this sometimes. Can you see this? I don't know if you can see it. Maybe. How can I make this visible? Guess what? I use this command. See if you can read this. Barely. Let me try it again. A little bigger. To open up Weka. Can you read this or not? Let's see. Now I think you can read it. Okay, Java, this stuff. This is the location of where my Java program is. So yours might be different. You might have to change this part here to, maybe you don't have x86 there or something like that. This is the location of where my Java Weka.jar, which is, I guess, the program. You want to do this, so you might have to change this. For example, yours might be like without this, might just be program files without that. I might delete that. Okay, but what I do is this is to increase the memory that Weka will use, and here I'm going to use 3 gigabytes, which is kind of a lot, but that's what I'm going to use. So what I do is I use this command, and then I right-click on the. You can't see this here, but I'm opening up the command prompt, and I'm going to. You should open it by right-clicking and do run as administrator when you do that. So I'm doing that now. I'm opening up the command prompt, but I'm doing run as administrator, and it asked me if I should do that, and I get this command prompt here, and then I will paste this in. And now when I run it with more memory. Okay. So I get this. This is the way it opens up in this case. And I go to here, and I choose Explore, Applications Explorer. I get this. Okay. Now I have a file here. I have a couple files here. One is Goodyear and the other is tires. So like if I look at the Goodyear one, see if I can fit this in here. So this is just like your file. This doesn't have the sentiment on it, which doesn't matter whether it's there or not. And the text is what we're interested in here. We have different texts here. Okay. This file is kind of small. There's only 1,248. Whoops, you can't see that maybe. 1,248 different tweets, whereas this one, tires, is much bigger. So same kind of file, but there's 33,000 of these. So I think the tires one is probably closer to the ones that you guys have in terms of size. So I'll use that one in this example. Now again, you know, if you get problems when you're opening up files, the only way we can fix that really is open it up in Notepad, and then look for. It'll usually give you a message as to which line it is. So like if it says it's a line 11, usually the problem is probably on line 10, but it's not necessarily that way. But you have to go through and try and figure out what the problem is. Like, is there a comma in there? Is there some other weird character in there. So you just have to look at it. There's no way that we have at this point to handle that. Okay, so let's try it now. So I want to show you how to convert it. So I have Weka, and I'm going to open up, I'm going to use the tires one. Let's see if it opens or if I get an error. I have to switch to CSV and tires. So let's just open it directly first. No. So let's see, what's this? A nominal attribute text cannot have duplicate labels. I have no idea what that means. But I've never seen this error before, actually. But actually, I usually open it up a different way. So let's see if I open it up the way I usually open it up, which is usually I'll click this first, and then tires, and it worked. Well, no, it didn't work. And I'll do this as for. Oh, it did work. Okay. So what was that for there for? Let me go back and check and show you that. So if you have, I think it's if you have strings. So this field, this text, like for example, this field followings, is numeric, and this one is numeric. These are strings. This is a string, really. This is definitely a string. Okay, and location, maybe it's a string. It's got commas in it. I wonder what that's going to do. Anyway, it didn't seem to care about that. This could be a string or a number. This is whatever, something. Okay, so notice that this is the field that we're interested in. This is the field that I want to convert to words, to individual words. This is the fourth column. So take note of that. This is the fourth column. Okay? So watch. Since it's the fourth column, when I open this up in Weka, I'll do it again. I open up, I want to click this or select this, tires, open, and here it says, do you have any string attributes? And the one that we're going to indicate as string, we need to indicate as string, is the fourth attribute, the text field, like that. And then it seems to open up. Okay? Okay, now this is familiar to you. We had the tweet ID field, the date field, the username field, the text field, this, and this. Now the text field, when you click on it, you don't see anything over here. Whereas in the username field, you see all the different usernames. Okay, there's here's NW4 Diesels. They had 11 tweets in this set. Okay, most of them are only one tweet, count as one. This person, Craig's Car M, they had 50 tweets in this data set. So some people are tweeting a lot. Probably, since this is about tires, they're probably advertising tires or something like that. Okay, so anyway, we have this and we've opened it up. Alright, now what do we do? It would probably be good if I showed you the end result first. So I'll do that first, just to show you what we're trying to get. Okay, I just ran through it just so I could show you what I'm trying to get. So this is what I'm trying to get. To see it, I'll open up this button here. Okay, now just to let you know, I paused the video. It took about 75 seconds for this to open up, I guess because it's so big. But this is what I'm after. This is what I want you to get. So what I have here up at the top, these are kind of weird, but if I scroll over, what I have here up at the top is all the different words in all of these tweets. So this is like a list of every word that occurred in the tweets. So follow was a word in at least one of the tweets. Forward was a word in at least one of the tweets. Found was a word in at least one of the tweets. So this is up at the top is a list of every possible word that was in the tweets. Now that's not quite true because I made one change to that, but basically that's what we have up top. And then what we have a big matrix here. This is the first tweet, this is the second tweet, this is the third tweet, this is the fourth tweet, the fifth tweet, and so on. And what we have is, for example, see if we can find at least something that's not 0. Here, for example, this word, here's a 1. So this means that this tweet, which is I guess the fifth tweet contained this symbol, or this word, contained an at mark, I guess. So the fifth tweet had an at mark in it. So let's see if I can find anything else that's not a 0. Most of these are zeros. In fact, they're all nearly zeros. So can I find something that's not a 0? Hardly. Not really. Oh, here's a 1. Okay, so the fifth tweet contained the word nice. Okay? Because there's a 1 there. Okay? So what this is every time, for every word that occurs in the tweet, we get a 1, and every word that doesn't occur in that tweet, we get a 0. Okay? So that's what this matrix is. And this is called, sometimes it's called a term frequency matrix, and sometimes it's called a frequency something matrix, but I think I'll call it a term frequency matrix. Okay, but it's clear what it is. We have, see if I scroll down, I should have all 33,000 tweets, and then I have the words across the columns. Okay, and these are the other variables that were in each of the each of the rows. So we had the tweet ID and then date, the username, the location. So that's also in there. Okay, so this is what we want to get. This is called the term frequency matrix. And once we have this, then what we've done is we've turned all of our tweet data into a big matrix. And this is a numerical matrix, except for these columns over here, which actually I'm going to delete anyway. But this is a numeric matrix. So it's a big, huge matrix. It's a numeric matrix, and we can do data mining on it because of that. Okay, so that's what we want to get. Now, if I want to show you this, so I close it. I wonder how long it's going to take to close. So that also took a really long time to close. It took about 40 seconds just to close it. Okay, now if I want to save this as to see, so I can open the results, say in Excel, I can just click here and save, and I'll call it tires TF for term frequency matrix. Okay, and I'll save that. Oh, now I have a problem. I didn't mean to do that, and I think it's, oh, this didn't work anyway. I didn't mean to save it as an R file. Let me try this again. Save. By the way, I think I should uncheck this when I'm saving, otherwise I get that dialog box, which is not what I want. And I want to change this to CSV file, and like that, and save it. Because when I did it before up here, oh, you can't see either of them. This one and this one, this was an R file, but if I right click on it, I think it's empty. Yeah, it's 0 bytes because of that dialog box. Okay, but I unchecked that unchecked that box, and now if this one is probably not. Yeah, it's huge actually. Wow. Okay. So anyway, if I open this up, you're going to see that same term frequency matrix, but you're going to see it in Excel. Okay, here it is. Okay, so this is what we want to get. And I want to show you how to get this. Once you get this, you can perform the analysis that I asked you to do for homework. So let's see this. Close that. Alright, so how do you do it? So we're in the Preprocess tab. We've opened the file. I'll undo what I did before. So we have this. And I actually, to make things simple, I'm going to get rid of all the other stuff. So I'm going to get rid of this, I'm going to get rid of this, I'm going to get rid of that, I'm going to get rid of this, this, and this. Now you may not want to get rid of this in the future, but for this exercise we can get rid of it, and I'm going to do it. So I just select the ones I want to remove, and then click remove. And now I only have the text field, and it's the first field. So if it wasn't the first field, you'd take note of that, and you'll see we need to enter what field it is in one of these boxes. Okay, so now I go to here, and I need to choose a filter. And the filter that I need to choose is listed under the unsupervised filters. Okay, click here, there. It's under the unsupervised filters. And then it's an attribute filter, not an instance filter. So I'll click here, and it's at the bottom of this attribute filter list. So it's here. And it's called string to word vector. So basically each row was turned into a vector. Each tweet was turned into a vector. And so that's why this is called string to word vector. We start with a string and we turn it into a vector. Okay, so I'll select that one. And then I have this up here. And then I have to set the options in here. So I click on here. So I click on here, and I need to set these options. And the options that we're going to set, now remember I just said that this was now the first field. But if it was the fourth field, I would change this attribute indices to 4. But it's not 4, it's 1, so I'll change it. I'll put it at 1. Okay? And then the other things I have to change is this one. Do not operate on per class basis. And we have to change that one to true. Now if you want to know the meanings of these, you can click up here on more, and it'll give you some description of each of these options. Okay, but anyway, you do need to make this true. And I want to make all of the words in the top column that we saw, I want to make all of those words lowercase. So I'm going to make this true. Lowercase tokens. They're called tokens. Once we split them up like that, they're referred to as tokens. And down here, use the stop list. I want to make that true. That means the stop list are words like to and the and so and so on. These kinds of particles, or articles I guess they're called, and so on. There's about 128 of them. You can change the stop list. You can make your own stop list. But anyway, I want to use the stop list to not include those words. I don't want those to be in the list of words at the top of the matrix. And then the other thing that we have to do, or two other things we have to do actually. This one first, the output word counts. Click true. So output the word count, how many words there are, how many times a word occurs, as opposed to just like a 0, 1 indicator. The actual number of times that it occurs. And then this one. This is the main one we have to think about. The minimum term frequency. So if I leave this at 1, I'm going to get, just like I said, every single word that occurs in any of the tweets. But that's going to be too many words. That's going to be probably like 1,500 or maybe, I don't know, even 2,000 different words. And I don't want to have that many columns in this matrix for various reasons. But I don't want to have so many columns. So I need to change this. Now if I make this, say, usually I make it like 15, but I just tried it, and I even tried making it 25, and I still had a lot of words. I even tried making it 50, and that's really unusual, but I guess because it's such a big file, 50, I still get about 900 terms across the top. So I think just to make this, well, especially for this this exercise, when we're doing the multidimensional scaling, I want to make it relatively small. So even 100, and I've never really done 100 before, except for today, even 100 is going to be too big. But let's just try 100 and see what happens. I mean, too big, I'm going to still get too many words. So let me put it at 100 and see what happens. I'll click OK. Okay, so now I have it with the options set, and then I just click Apply. And here it is. Now I can scroll down and see all the variables, meaning all of the entries at the top, the entries at the top of each column, and see how many there are. Okay, there's 427. That normally would be not so many, actually, and that would be okay. So for most things that we want to do, that would be about the right number to have. Now, as I said, I've really never used this 100. That means, what this means is you have to have it. The word has to occur in at least 100 times before it will be included as one of the column headers or column names or column labels. So it has to occur at least 100 times. So that means that, for example, this word live or live occurred in at least 100 tweets, or at least 100 times. And this word makes occurred at least 100 times, and so on. Okay? So, but actually, just I think, now, this is one way to reduce the number of columns that we have in that matrix, in that term frequency matrix. Other ways would be to manually delete columns, to go through it and choose the columns that you want, or choose the words that you want, and delete the other ones. By the way, the set of the words that you decide to have, or the set of words that you use, is called the dictionary. It's called the dictionary. So we want to prune the dictionary, or make the dictionary smaller, or so that's what we're doing here. So right now our dictionary is of size 427. Now one way to change it would be to manually look for sort of interesting words and delete uninteresting words. And for example, if you have words that sort of mean the same thing, but they're different forms, like work and working, you might want to combine those into one. Just make it work, or just make it working, and not have both of them. Okay, because, but, so I think still we have too many words here. So I'm going to go back. First I have to undo what I've done. You can't go back and run this until you've done it first. So I undid it. Back here, and I'll try, I don't know, I've never done it this big before, but I'll try 150 and click Apply. Now how many do we get? Okay, now we get just 200. Alright, I'm going to leave it like that. And also, I want to get rid of these things up here. These are kind of, I don't really want to see these in that multi-dimensional scaling diagram. So I'm going to remove them. So if you don't want to see those results in the multi-dimensional scaling, like I don't really want to see this plus sign in there, you remove them. And you click remove. Okay, and at the end there's some weird ones also. And then you can also go through here and say, I don't want to see that, I don't want to see this, I don't want to see that, I don't want to see that. Or maybe I'll leave that in. And you can decide, you can prune it this way as well. So I don't want to see that, I don't want to see that, I don't really know what that means, I don't 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 want to see that. Okay. So like I don't know what that means, so I'll get rid of these. So you can go through and prune this manually. This is one way to prune it manually. You know what this means? RT means retweet. I'll leave it in. Alright, so I'm not going to go through all of this and remove everything, but there's words from other languages that I don't want in here. So I'll just remove them. Anyway, so you go through and you prune it. So now I have 189 words. Okay. That's not, maybe that's okay. Alright, so now it's done. Now if you wanted to do some classification algorithms, now you can do them. Like if you wanted to do a neural network or a tree or something. But right now we don't really have any. We took out the other variables. I removed them. So I don't know what we try and predict here. So I'm not quite sure what kind of neural network we could try and run, because neural network, you're trying to predict something, and I don't really have any variables that I'm trying to predict here. But anyway, you could, if you wanted to, do that. Okay? You could also do the visualization that we talked about, where you could look at the correlations, or you could save this in as an Excel file and look at it in Excel, look for correlations. That would be correlations between the words. So for example, does winter occur frequently with work, or something like that. Now probably the correlations are going to be quite low, but it might be interesting to check them, and if you found some that were high, that would be an interesting thing to report. Anyway, but you're going to have a big correlation table, because it's going to be 189 by 189. Okay, so let's save this. I'll call it the same thing I called it before. Actually, not the same thing. Now, you should uncheck this, and I don't want this to be an R file, because I'm going to be doing using Excel on it in the multi-dimensional scaling. So here, save it, and now I can see it here. Let's open it, see what it looks like. So it still has many, many rows. The columns, there's 189 columns. Okay? It's huge in terms of the number of rows. Okay, now you want to do the multi-dimensional scaling on this. Now let me tell you that the Excel stat application, which is where the has the multi-dimensional scaling function in it, is located in our folder. So you don't have to download it from the internet. You can just get it from our class folder. And you might try and do this on on a school computer, you might try and install it on a school computer. I'm not sure if it will install on a school computer, but if it does, you could install it there, because once you then you won't have to worry about the 30-day trial period. If you install it on your home computer, then you only have 30 days to use it. So it's up to you. So I'd like you to do the multidimensional scaling that we did in class. Now remember, and I can't remember right now, whether I think we needed to take the transpose of this matrix. I'm pretty sure we had to do that. So let me show you, just remind you how to take the transpose. So you select the entire matrix first. And all the way down. I hope this works with such a big matrix. So there it is. I think we need to take the transpose in order to get the picture that we wanted, where we had the names of the... I want to have the words on the multi-dimensional scaling graph. So I think we have to do that. So copy and go to another sheet and paste special. Let's see if this works, if it's too big or not. I guess it depends on the memory in the computer. So I'll try it. No, it's too big. Oh, wait. Maybe it's not too big. Why didn't that work? Or maybe it is too big. Okay. I wonder if it's because it's a CSV file. Let me try saving it as an Excel file first. Because Excel has a limited number, it might not have 33,000 columns. You may not have that. I forget how many columns there are in Excel. So let's see, let's try it again. Copy. Here, this is Excel now. And paste special. Transpose. No. Okay, so maybe doesn't work. So there are ways to get the transpose of this, but if we want to do the analysis in Excel, we need to have that many columns, and I don't think we do have 33,000 columns, although I'm not sure of that. So in that case, let's try not copying all of those rows, not all 33,000 rows. Let's see. Let me try that. So let me go all the way to here. Let's try this, just 15,000. And now let's go here. Paste special. Transpose. Okay, there, it worked. Alright, so that's good enough for our purposes. So if you copy, if you have just 15,000, that's okay. That means I'm not taking all of the data, so I'm not taking all of the tweets. Probably, I don't know if it was organized according to date, but I might be taking only like the first, the earlier tweets. Okay, anyway, we have this, and then you need, so as I said, I'm not, I think what we want to have to do the multidimensional scaling is to have these as the along the first row, not in the columns. So you can try it either both ways and see which one gives us the words on the display of the multidimensional scaling graph. Okay, because what we're looking for is like clusters of words or locations of words. Okay, so that's going to be your assignment, to go through that, and I'd like you to then, after you get the picture, I want you to analyze it. So make intelligent observations about the way it looks. So we said that when things are far apart, means they're different. When things are close together, means they're the same. You can look for clusters of words and so on. And if you find that you have too many words, like if I find that 189 is too many, then make it smaller. Trim it down somehow. Manually, you can trim it down to include just interesting words. Okay, words that show something about the stock or about the company. Okay, so manually prune it to make it a smaller set of words, and then the picture that you get will be less complicated and more understandable. Okay, that's what you need to do.